Okay guys, how are you all? Are you all doing good? So today we'll be solving questions from week 4 lectures, right? So that will be mainly from sequence and limits. Okay, and so I'll be starting from question number 1, and then if I would require any theories, I will I'll parallelly do it. Okay. So first, the first question I'll start with sequence. So I hope you guys have seen the lectures, listened to the lectures from week 4. I think this is like 4 or 5 lectures were given, right? Mainly from convergence of sequence, limits of sequence, and then there were another few topics: ratio test, Cauchy theorems, limit of sequences, and criteria for convergent sequences. Okay, and also some results on limits and Bose-Weierstrass theorem. So yeah, without wasting times, let us start the first question. Okay, so if you guys have any doubt, let me tell it in the beginning. You can always ask me. Okay, this is like one-time opportunity, and if you do not want to speak, you can just type in the chat. Okay, so yeah, let us start the first question. So this is question number 1. The sequence an equals to 1 divided by square root of n into n plus 1 plus 1 divided by square root of n plus 1 into n plus 2, and so on, like this. 1 divided by square root of qn into 2n minus 1. Okay, is so here is the first option: monotonically increasing and bounded below. Monotonically increasing and bounded below. Second option is monotonically decreasing but not bounded below. Okay, third option is convergent. And fourth option is divergent. Okay, so is this question clear to everyone? So as I said earlier, if you don't want to speak, you can just put thumbs up, yes, no, or whatever you want to write in the chat, so that I can understand you guys are following with me. Okay, so yeah, you can just give a try. that if you can solve it or not. Okay, and then I'll discuss the solutions. So probably you have seen sequences mean like it starts from some numbers, right? Like for example 1 by 2, 1 by 3, and so on, like 1 by n. But this looks a little bit different, right? Because it's starting from n, right? Like the nth term has a different structure, like sum of n terms, right? With some sort of algebra is there, like square root of n into n plus 1 and so on. So like what is like your approach, like when you see this question, how do you want to solve it? Do you guys know anything? You can share with me if you have any suggestions or any like anything, any comments. Anyone? So one thing to notice here that so n is written as a sum of sequences, right? Like sum of some n terms, right? So that means you can write n like this. Something like k into k plus 1, right? Is it understandable how it comes? So this is k equals to n to 2n minus 1. And for example, if you put like k equals to n, then the first term is 1 divided by square root of n into n plus 1, right? Similarly, if you put k equals to n plus 1, it will be 1 divided by square root of n plus 1, then into n plus 2, right? Because k is just n plus 1. So now one thing to notice is that okay, so in the last class I discussed, I think, one theorem that is called the sandwich theorem, right? Or you can say it as squeeze theorem or mousetrap principle, whatever you say, because all things are same. So what I discussed was that if there are three sequences an and bn and cn, such that an less equals to bn less equals to cn, and the limit of an and cn are same, then the limit of bn will be also same. Correct? This is called squeeze theorem. So now my goal is, if I can show that the sequence an lies between two sequences bn and cn, and the limit of bn and cn is same, then only we can show that the limit of an is same. Because in that case, the limit of bn and cn may be easier to find out, right? So let us try to see that how we can define an between two sequences such that that limit of an is same as the left side limit and the right side limit. Okay. So one thing to notice here is that 1 divided by k plus 1 strictly less than 1 divided by k into square root of k into k plus 1 less than 1 by k. Okay, so this has to be observed first. Okay, before I solve this question. So if you guys have understood this observation, then there is nothing more in the question. Okay, if you have understood this relation, then the question is solved. So yeah, like I just wanted to know if you guys are understanding it. So if you are like, if you do not want to speak, as I said earlier, you can just type in the chat that you are not getting it, then I'll explain it again. And also if you are getting it, you can just tell me that yes, we are getting it. or just simply yes. Okay, so is this clear how why this happens? I mean, at a fast glance it may not look that it does follow this inequality, but it's easier to see, right? So maybe I'll show one side, then another side is easier, right? So notice that 1 divided by k plus 1 square is less equals to 1 divided by k into k plus 1. So no matter what natural number you take, this is always true, right? So can anyone tell me, please, for a second, why this holds? Anyone? Any idea? So on the left side you can see that k plus 1 square is just k square plus 2k plus 1, right? Because this is same as k square plus 2k plus 1, and this is same as k square plus k, correct? And we all know that k square plus 2k plus 1 is strictly greater than k square plus k. So then whenever you take the inverse, that means when you take the reciprocal, the lowest term will be the highest, correct? Because if 3 is greater than 2, then 1 by 3 is less than 1 by 2, correct? That means in this case 1 by k square plus 2k plus 1 will be strictly less than 1 by k square plus k. So similarly you can prove the right side as well. Okay, is this clear to everyone? So yeah, if you have any doubts, do not hesitate to ask. As I said earlier, again, this is like one-time opportunity for you, so you can ask me questions if you have any at any point. Okay, so I hope this is clear to everyone. Then the question is easier now. So then what you can show is you can just take sum on both sides, right? This is what you want, because we have got the 1 divided by square root of k into k plus 1 term, and then just we have to take sum on both sides, correct? So this will imply summation of k equals to 1 to 2n minus 1 summation of k equals to 1 to 2n minus 1 divided by square root of k into k minus 1, and then again k is equals to 1 to 2n minus 1 1 by k. Okay, so this is what we are getting after taking the summation on both sides, like on all the sides of this inequality. Correct? This one. Okay, so now the question is, what is the limit of this one and this one? Is these two limits same? If these two limits are same, then only we can say that the limit of the middle term exists and it is equals to the both LHS and RHS limit. Okay, so yeah, can anyone okay, so should I solve it, or like should I give me like another 1 minute to solve? Okay, so since you guys are not answering, so let me solve it. So first see that n plus sine square of n divided by n plus cos of n. This is same as 1 plus sine square of n divided by n by 1 plus cos of n divided by n. Okay, so now that means we have to find out the limit of this term. Now we don't have to find out the limit of the first term, right? So to find out this limit, you have to just check the limit of sine square of n divided by n and limit of cos n divided by n as n goes to infinity. So now please tell me what is the limit of sine square n divided by n or cos n divided by n. Are you guys following it? As n goes to infinity, what is the limit of cos n divided by n? Anyone? Yes. Yeah. Yes. So yeah. So sine cos are bounded function definitely, because it always lies between -1 and 1. But why do you say that it like for example in the case of cos n divided by n, why do you say this cos n by n goes to 0? Like, are you using some theorems? Like, I just wanted to know. I mean, like, how you say that if cos n is bounded, then cos n by n is going to 0. I mean, like, are you using some facts or some theorems, lemmas? You can just tell me the lemma. I don't need the proof that this particular lemma fact you are using to show that cos n by n is going to 0 as n goes to infinity. Okay, so we have to evaluate limit n tends to infinity sine square of n divided by n and limit n tends to infinity cos of n divided by n. So we have to evaluate these two limits, right? So before that, C is correct, Dipashri is correct. So she said that the limit will be 0, and in fact it is 0. I mean the limit of both sine square of n divided by n and cos n by n. But before that, I'll write one fact. Yes, this is true, but how do you combine these both? This is indeed true that cos n is bounded, sin n is bounded, and 1 by n goes to 0. But then how do you combine these two? So are you saying that if one sequence is bounded, another is going to 0, then the product will be going to 0? Do you claim that? And if you are claiming that, this is true, right? This is what I am going to write in the next fact. So if a sequence is bounded, right? If a sequence is bounded and another sequence is going to 0, the product will be going to 0, right? And the proof is also very easy, correct? So this is fact 1. So if an is a bounded sequence and limit of bn is 0, then limit of a and bn is also 0, correct? This is what we are using, right? Because for example, for the first sequence sine square of n, which is always bounded between 0 and 1, correct, and 1 by n goes to 0, so that means sine square n divided by n will goes to 0, correct? Similarly, You take an to be cosn and bn to be 1 by n. Cosn is bounded, bn equals to 1 by n is going to 0, so the product will be going to 0. Correct? Hence, by fact 1, limit n tends to infinity, sine square of n divided by n, and limit n tends to infinity, cos n divided by n is 0. Correct? So, limit n tends to infinity, n plus sine square of n divided by n plus cos of n is what? This limit is 1, right? Because this is going to 0, this is going to 0, so this will be 1 by 1, which is 1. Is this clear to everyone? Please tell me if you have any doubts. As I said earlier, you can just write in the chat if you don't want to speak. Okay? Or you can just put thumbs up if you have understood. Okay? So yeah. Yeah, so that means Binu has understood, Divya Lochan has understood. What about other people? Are everyone getting it? You can just put thumbs up that if you have understood, then I'll go to the next question, right? So yeah, okay. Okay, I hope everybody has got it. And if not, you can ask me question anytime, okay? During this class. So then I'll go to the next question. This is an interesting question which has been asked in many competitive exams. Okay, so if you are like preparing for competitive exams such as NET, GATE, JAM, or others exams such as CMI, ISI, TFR, so this question may be helpful. Okay, so the purpose of this assignment solving class, or this discussions, are not just only solving question, also to explore possibilities of other questions that are appearing in different competitive exams. Okay, so yeah, this is an important question, and I'll put 1 star for this question, or let us put 2 star. So for alpha in Q, evaluate limit n tends to infinity limit of sin n factorial alpha pi. Okay, so do anyone have any idea how to solve this question? This is a very interesting one, right? Because in general, sine function is bounded and oscillating, right? Because we know that limit n tends to infinity, sine n does not exist, right? How many of you know that limit of sine n does not exist? Limit of cosine n also does not exist. So yeah, anyone wants to answer anything? So you can take 1 minute to think, and if you have, like, if you're getting any hints, then you can just tell me. It can be wrong also, doesn't matter. Any idea? Any comments? So notice that for given rational number alpha, so alpha has been embedded inside the function, right? Yes, this limit is 0, but yeah, how do you know? I mean, like, how did you solve it? This will be 0, in fact. Yes, because alpha is a rational number, so yes, of course, because alpha is a rational number, so alpha can be written like p divided by q, where p is integer, q is natural number, and then what's the next step? Okay, so do you mean the small q? It's not the capital Q, right? Yeah, I mean, I think in the as you said that as n goes to infinity, q will get cancelled. Is like not like not appropriate to say mathematically, but it's like as n goes larger, q will get cancelled out, right? I mean, after some n get equals to q, right? That means inside will be an integer. Yes, 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 yes. And sin n pi is 0 always, right? Okay, yeah, I think, yeah. So yeah, C is correct. So the answer should be 0. So let me explain what is going on here. So note that alpha can be written as ratio of two integers. So even specifically you can say that alpha equals to p by q, where p is an integer and q is a natural number. So remember, here alpha is fixed, okay, given any alpha. It's not like for every alpha. So the question you have to like understand fast. So here I'm giving you an alpha, and then you have to evaluate the limit of sin n factorial alpha y, and it is of course that alpha is arbitrary. So given any alpha, it does have a unique representation. So I think I explained it in the very first class, and indeed we can show that alpha can be written as p divided by q, where p is an integer, q is a natural number, and GCD of p comma q is 1. Okay, so that's why it's called an unique representation, because 1 by 2 and 2 by 4 is eventually same, but 1 by 2 will be the rational like unique representation of the rational number 0.5. Okay, so now see that if alpha is p by q, then you have to evaluate the limit of sin of n factorial p by q into pi, correct? So sin of n factorial alpha of pi is same as sin to n minus 1, or 1 2 into I'm sorry, this will be sin of 1 2 and n minus 1 into n, okay, into p by q into pi. Okay, so these dots are all products. Okay, so now notice that if q is greater equals to n, sorry, if n is greater equals to q, then q will be cancelled out. correct? Right, because if there is like 5 factorial and there is 1 by, let's say, p by 4 factorial, then this 4 factorial will get cancelled out, or let's say just 4, then this 4 will be getting cancelled out, right? You can take even 4 factorial, 5 factorial, 6 factorial, whatever you say, take, because 4 will be contained in the 5 factorial, correct? So if n is greater or equals to q, this will imply that sine of n factorial alpha of pi is 0, because as long as n is greater or equals to q, q will be cancelled out, and a factor of q will be always present inside of n factorial, because n is greater or equals to q, correct? So that means that 1 to n factorial after cancelling out q will be a natural number. P is an integer, the product will be an integer, so integer product of pi is always 0, right? Because we know sine of n pi is 0. So this is implying as long as alpha is a rational number, no matter how big it is, the sine of n factorial alpha pi will be an eventual zero sequence. So also in the last class I explained what is an eventual constant sequence. So in this case you can see that sine of n factorial alpha pi is an eventually constant sequence, correct? Because it's becoming 0 after n greater or equals to q. After the natural number q, sine of n factorial of alpha pi is 0. So that's why its limit is 0, because it's a constant sequence. After some certain terms, all the terms are becoming 0. Okay, so I hope this is clear. Probably I have over explained. Okay, I assume I have explained like more than it required. So then let me go to the next question. Is there any doubts? Anyone? For what about other Dibyalochan, Binu, Rashmita? So I assume everybody had understood. So let me go to the next question. So the next question is question number 4, and this is also an important one. Okay, so also I'm gonna put 1 star for this question. Suppose n is not equals to 1 for all n, and limit of an is 1. Okay, so evaluate limit n tends to infinity, limit an plus n square plus an cube plus n to the power 4 minus 4 divided by an minus 1. Okay, so let me give the options as well. 4 minus 4, 6, and then 10. Okay, so let me explain the question again. So here n is not equals to 1 for every n. Limit of n is 1, and you have to find out the limit of n plus n square plus n cube plus n to the power 4 minus 4 divided by n minus 1. Okay, so anyone, any, yeah, any comments, anything you want to give in an attempt? You guys can try it. Okay, it can be wrong, it doesn't matter. So yeah, you guys can just put in the chat if you have any opinion. Yeah, are you guys following it? Okay, then what are you gonna do with the split? Yeah, I mean, of course you can split it by writing as a sum of -1 4 times, but like, what are you gonna do with the split? I mean, do you have anything in your mind? Yeah, anyone? uh, but see, in the denominator there is n minus 1. You cannot take limit, right? Because it will be 0. Limit of n is 1. In the denominator you cannot take the limit. So I don't know if you have seen in the limit chapter. So if you are evaluating a limit, the denominator should not be 0, right? You cannot just take the limit right now as it in its current form, at least. Yeah, but this doesn't help, right? Like after that, okay, but then what are you gonna do with the split? In the denominator there is an n minus 1. So let's say the first term will be 1 because n minus 1 will get cancelled out. What about the second term, third and the fourth term? Yeah, this is a good attempt. Okay, so you can try like this. Okay, at least you have to try. These are good attempts to see in the very first sight. So yeah, let me show it how to solve it. Correct. So one thing you notice that is that whenever it is necessary, I don't know if you guys have seen it in the limit and continuity chapter. So whenever it is necessary, you can just interchange between limit of sequence and limit of a function when it exists, obviously. Okay, so one thing to notice here is that x plus x squared plus x cube plus x to the power 4 minus 4, this is same as, okay, so let me write in the next page. X plus x squared plus x cube plus x to the power 4 minus 4 into x minus 1. Okay, and then x cube plus 2x squared plus 3x plus 4. Okay, so you can write the product, I mean the whole term, like this. So let's just assume that x to be an. What's the problem, right? In the function chapter you have seen that, right? If the limit exists of some function, then there exists a sequence an in the domain such that an will converge to that limit where x is converging, and then corresponding f of an will converge to the main limit, right? This is what you have seen. So that means similarly also you can just replace x by an. So you can write an plus an square plus n cube plus n to the power 4 minus 4 equals to an of minus 1 n cube plus 2n square plus 3n plus 4, right? So that means similarly you can replace x by an, correct? Is it clear? So that means limit an tends to infinity, an cube plus 2an square plus 3an plus 4 divided by an minus 1. No, this is not a formula. This is just a product of two terms. I mean, you have to observe this actually. So I'm just showing you to write by x. There is no such thing here. I mean, I'm not replacing an by x here. Okay, so if you want, you can just write in terms of an, that an plus an squared. So this is like sometimes easier for me to write instead of an. So I think you guys are getting it confused. So yeah, let me write it in terms of an. So an plus an square plus an cube plus n to the power 4 minus 4 equals to n minus 1 n cube plus 2n square plus 3an plus 4. Okay, is this clear? Now is it clear? So that means the whole sequence can be seen as a product of two sequences. You just do the product, you will get the left side. So sometimes if you replace an by x, it will be easier to do the calculations. So that's why I wrote it like that. Because since it is given that an not equals to 1 for each n, your first goal is to cancel out this an minus 1 from both like denominator and numerator, right? Because in the question it is given that an is not equals to 1, right? For all n is never 1. Yeah, I mean it is easy to see that, right? Because if you put like n equals to 1, then it getting cancelled out. So that means if you see this polynomial, if x equals to x plus x square plus x cube plus x to the power 4 minus 4, then it is easy to understand that f of 1 is 0. Correct? So that means you got an idea, right? That 1 will be a factor. That means f of x can be written like this. Correct? This is from algebra. So if you have studied the basic algebra of bachelor's, BSc, then you might know this. Correct? So now what you're gonna do? You're gonna just divide by x minus 1. Okay. So if you do the division, you will get the quotient. So should I do it, or will you guys will be able to do it? So up to do this, is it clear to everyone or not? So the main question was how did I get like the factor, right? How do I get this one? Correct? This was the main question, right? So now it is clear, right? So that's why initially I wrote it like this, because if you write n as a x, then it will be much easier to explain, like much easier to understand for you and for me as well. So you see as a factor of as a function, right? Then you see that f of 1 is 0. So that means x minus 1 will divide the polynomial. It is a polynomial, right? And by the fundamental theory of algebra, the lower degree polynomial will divide the highest degree polynomial, because 1 is a root. So it can be written as x minus 1 into q of x, where q has a degree 3, because the main polynomial has degree 4. Correct? So now if you just do the division, you're going to get that polynomial. So in fact, you can write this. So after the division, you will get qx to be x cube plus 2x square plus 3x plus 4. And this is what we have written in the top. X minus 1 into q of x, and x will be replaced by an. So an minus 1 into an cube plus 2n square plus 3n plus 4. Correct? So this is 4. Is it clear? Rajnit? Who was this guy? Sorry, Ranjit Kumar. Is it clear? Okay. So it's coming from an understanding of like you have to visualize it sometimes. Like if there is a factor in the denominator, you should try to cancel it out in the beginning. Okay, so this will come with practice. So you just try to put x equals to 1, you see what is going on, right? You just put x equals to 1, you see that the polynomial vanishes. So that means 1 is a root. 1 is a root of the polynomial, or 1 is a 0 of the polynomial. If 1 is a 0 of the polynomial, so x minus 1 will divide the polynomial, right? And by the fundamental theorem of algebra, you can write is a product of other roots also, right? So product of the factor, that is x minus 1, which will divide the polynomial, and then the other polynomial q of x, which has degree 3. And if you just do the division, just like I show it, you're gonna get this polynomial, x cube plus 2x square plus 3x plus 4, and just you replace x by a of n. Correct? So yeah, I mean, I hope this is clear. So limit n tends to infinity, n minus 1 into n cube plus 2an square plus 3 of an plus 4 divided by n minus 1. Now we have already written in the question that an is never 1 for any n. So this will get cancelled out and we are left with this term. Correct. So now we can substitute the limit of an because we know that limit of an is 1. So this will be 1 plus 2 plus 3 plus 4, which is 10. Is this clear to everyone? If you have any doubts right now, you can ask me. So this is like now or never. So please see it again and tell me if you have any doubts. Because this type of questions will be solving later, and also in the exams, like tons of questions have been asked like this. Okay, so maybe the question will be different, but the idea will be same. So the approach is same, kind of. So shall I go to the next question? Do anyone have any doubts so far? Pinu, Dibbalochan, Dipashri, Hema. Do you guys have any doubt? Okay, so I hope you guys have got it. Then let me tick the correct answer, which is 10, right? Okay, so let me go to question number 5. So the next question is for modulus of x less than 1, compute limit n tends to infinity, product of k equals to 0 to n, 1 plus x of 2 to the power k. Okay, so x power 2 to the power k, where k is varying from 0 to n. This is also a very good question, I assume. I mean, I think it is a good question. So yeah, anyone have any lights on how to solve this question? So yeah, you guys give it a minute to try. I'll just come within 1 minute. Okay. Yeah. Any any comments, anyone? So shall I solve it, or so it is x power 2 to the power k, okay, so not x square power k. So like if you put x equals to, sorry, k equals to 0, it will be x to the power 2 to the power 0. So this will be just x. If you put k equals to 1, it will be x square. If you put k equals to 2, it will be 2 square, so that means x to the power 4, and it's goes on like this. Yeah. Shall I solve it, or like do you guys have any opinion, any answer? Okay. So yeah. So it's like after, so you what you can do is you can try to see first what is this nth product of 1 plus x to the power 2 to the power k. Okay, so you can see that 1 minus x into 1 plus x is 1 minus x square. Yes, yes. I think Ranjit has got it. Yeah, I mean, yeah, I think, yeah, this is approach you can follow. So this will be just product 1 minus x to the power 2 to the power n, right? Ranjit? Divided by 1 minus x. Correct? Yes. So that means you can show that by finite product, okay, 1 minus x into product of k equals to 0 to n, 1 plus x power to the power k is 1 minus x power 2 to the power n. Okay, is it clear? But Ranjit, one thing is that by this you will get the sum, not the product, right? Because in the beginning I thought this is the sum. This is the this is not the sum, right? This is the product. So this is not the same with our question, right? Because I didn't notice it in the beginning. So there is a product here, right? Not sum. If it is a sum, then only you can write like this. Yeah, I mean, in this product, yeah, in this case, I think you cannot write like this. You'll never get this expression. Okay, so this is x, not n. So how many of you can get this expression? Yeah, my handwriting is not that good, but I hope everyone is getting it. If this is clear, then there is nothing more to explain here. Is it clear to everyone? Is it okay? Shall I proceed? Okay, so one thing to notice here is that you have to just take the limit on both sides, right? Because we have got our expression. For the expression we want to find the limit, right? So limit of okay, so before that we have to determine whether the limit of this exists. Okay, if this limit does not exist, then we cannot take limit on both sides, correct? So first we have to determine that the right side limit exists. Now since modulus of x less than 1, this will imply that limit of x to the power 2 to the power n is 0. Okay, this is very standard, right? Kind of geometric series, right? Isn't it? So you take limit both side. So this will be product from k equals to 0 to n, 1 plus x to the power 2 to the power k, and this will be limit of 1 minus x power 2 to the power n. So this will be just 1, correct? So limit n tends to infinity, product of k equals to 0 to n, 1 plus x power 2 to the power k is 1 divided by 1 minus x. Okay, so if anyone asks you that for x equals to 1 by 2, what is the limit of this product of k equals to 0 to n, 1 plus 1 by 2 to the power 2 to the power k, so this limit will be just 1 divided by 1 minus 1 by 2, which is just 2. Okay, so this is corollary. Limit n tends to infinity, product of k equals to 0 to n, 1 plus 1 by 2 power, or in other words 2 to the power k, correct, is just 1 by 1 minus 1 by 2. This is 2. So you might think in the beginning that the limit is just 1 because of the right side going to 0 for each k, right? But you can find out that this limit is 2. Okay, is this clear to everyone? So just try for 1 minute again that if you have understood it or not, and then hopefully I'll go to the next question. So what we have done is we have tried to write the sequence as something on the LHS and something on the RHS, but we followed the identity that 1 minus x into 1 plus x is 1 minus x square. Similarly, you multiply both sides by 1 plus x square. So it will be 1 minus x, 1 plus x into 1 plus x square equals to 1 minus x to the power 4, correct? And you go on like this. Again, you multiply by 1 plus x to the power 4. So by finite product, so that means if you take this product up to n times for any given any natural number, so you're gonna end up with this box function. I mean this term inside the box, that is 1 minus x into product of k equals to 0 to n, 1 plus x power 2 to the power k is 1 minus x power 2 to the power n. So you can just verify it by putting n equals to 0 or n equals to 1, whatever you want. Okay, so and we know that modulus of x less than 1 will imply limit x to power 2 to the 1 is 0. that what I've seen similar in the geometric series, correct? So that means the product is same as, the limit of the product is same as limit of 1 minus x power 2 to the power n divided by 1 minus x. Now since limit of x power 2 to the power n is 0, so this limit is just 1 by 1 minus x, correct? So as a corollary, in the exam they can ask you question like this. They will put value of x which satisfied modulus of x less than 1. So for example, they can take 2 by 3 as well. They can take 1 by 2. They can take minus 1 by 2. Okay. So then accordingly, you just put the value of x to be 2 by 3 or 1 by 3 or minus 1 by 2, and then you're going to get the limit, because we have found out the limit for any general x which satisfied modulus of x less than 1. So probably you will see in the next like later lectures that this modulus of x less than 1 is just the interval of convergence. Okay. So like if you take any points between minus 1 and 1, this limit exists always. Okay. Also you will understand about radius of convergence, interval of convergence, and so on. Okay. So probably this will all come in the later lectures. So if this is clear, I'll go to the next question. So the next one should be question number 6. Okay. So question number 6 is given like a theoretical question, I can see. So still I am gonna write it. Okay. So consider the following statements. The first one is if an greater or equals to 0, so that means an is if a positive sequence an converges to A, then limit n tends to infinity a1 dot an 1 by n is A. Second option is if n is positive for all n and satisfies limit n tends to infinity n plus 1 by n equals to A, then limit n tends to infinity a1 up to an 1 by n is also A. And the third option is if positive n for all n satisfies limit n plus 1 by n is A, then limit a of n power 1 by n is also A. Okay. So the question is, which of the following is /R true? Okay. Is this question clear to everyone? So in all cases an is a positive sequence. In the first case, if n converges to a, then they are asking that, then saying that a1 up to product of an power 1 by n is a. The second is if the ratio limit has limit a, then similarly the product of a1 up to an to the power 1 by n is a. And if similarly if n plus 1 by n limit is a, then n power 1 by n has limit a. So which of the following is or are true? Like 1 is true or false, 2 is true or false, or 3 is true or false. So if you say some of the options are false, then you might have to give an counter example. Okay, so if you can give a counter example, or if you can give an example such that like some of the following statement do not hold, then only you can say that that option is false, like not true in general. So I think first one is very well known, right? Isn't it? Anyone? Any idea? So let me see what else are there. This is a good question. There are also other questions, similar questions, just resolve in the question number 1. Yeah, we'll see that. So yeah, any comments, anyone? Anyone? Anything on the chat? Ranjit, do you want to say anything? Divya Lochan, I think you didn't reply anything today. Binu, Hema, and also other people. Yeah, so this is mainly theoretical. I'm not gonna do the proof because each statement requires a proof of at least 1 pages. Okay, so the first one is very famous, right? The Cauchy's limit theorem, right? The second limit theorem, right? First is also same when limit n tends to infinity a1 up to an, sum of an divided by n is a. So first one is true, right? This is the Cauchy's limit theorem, right? First one is true. So what about the second one? Is it true? And also let me tell you that third one is also true. And please remember this theorem, or also you can try to see the proof in the SK Mappa book. As I stated earlier, as I suggested earlier, this like proof of this fact as a theorem is there. So you can see the proof why this happens. This is very, very nice result. Okay, so just remember this result, the statement 3 I'll be using in some question we'll be solving here today. So 3 is also a very good question, like statement that if the ratio has a limit a, then n power 1 by n will be also will be limit of a. Okay, what about the second one? So first and third are true. First is true by the Cauchy's first limit, second limit theorem. Third is true. Just see the proof in some standard book, it will be there. What about the second option? Is it true? Anyone? Yeah, it is false, right, Ranjit? Yeah, why it is false? it is indeed false. Can you give me a counter example? Do you have any example or counter example in your mind such that an will be positive, the ratio of the terms an plus 1 and an will be some finite limit, but the product power to the power 1 by n will not have any limit? I mean, obviously not a. Okay, so so option 2 is false. Okay, so let me give you the counter example. So you just take an to be 2 to the power n. So clearly this is positive for all n. So now what is an plus 1 by an? So this is 2 to the power n plus 1 divided by 2 to the power n. This is just 2, right? So that means limit n tends to infinity, n plus 1 divided by an has limit 2. So according to the statement, product of a1 up to an to the power 1 by n should be should be 2. If this does not hold, we can say that this statement is false. Correct? So let us try to see. Limit n tends to infinity, a1 up to an is what? So this will be limit n tends to infinity. Correct? So this is 2 to the power 1, 2 to the power 2 up to 2 to the power n. So this is same as limit n tends to infinity correct? Is this clear? So the base is same, so the product will be just sum of the powers, and this is same as limit n tends to infinity 2 to the power 1 by 2 into n plus 1, correct, into 1 by n. So n will get cancelled out, and this will be limit n tends to infinity 2 to the power n plus 1 by 2, correct? And this is infinite, you can say, or the limit does not exist, whatever you say. Okay. Or you can say just the limit does not exist. Correct? So, but according to the statement, it should have been 2. The limit should have been 2. Correct? This is what was given in the statement. So that means this option is false. This is not true. Correct? Because if this was true, this should have been 2. So this option is false. So first and third are only two options. Okay, so let me go to the next question. Question number 7. Yeah, any doubt in the previous question? I forgot to ask. There are also other people. Nilofar, Maths Department, Ranjit, Akash Patro, Pinu Embram, Dipashri, Dibalochan. Dibalochan, do you have any doubt? Yeah, Ranjit said clear. So yeah. What about Dibalochan? Okay, so Nilofar Maths Department is saying no, so he has understood. he or she has understood clearly. Okay, no doubt. Okay, so let me write the next question, which is question number 7. Evaluate limit n tends to infinity 1 divided by square root of n squared plus 1 plus 1 divided by square root of n squared plus 2 plus 1 divided by square root of n squared plus n. Yeah, this is also a very nice question. Anyone? Any idea on how to solve this question? Actually, to solve good questions from sequence series, like you have to really understand the structure of the question and some basic inequalities in your mind, like how to solve some terms are greater than some other terms, or like can you, so in this case that the sequence will lie between two terms, two sequences, both where both of the sequences have same limit, then using a squeeze theorem you will be able to prove that this limit has this, like the sequence has the same limit as the other two sequences. Like can you show that there exist two sequences, let's say bn and cn, such that this given sequence will lie between that two sequence. So let me call it an. Okay, so let me call it an. So can you show some sequences bn and cn such that like bn less equals to an less equals to cn and limit of bn and cn are same? Is it possible to for like is it possible? Can anyone do that? Yeah. Anyone? Binu? Can you give me some light? Some ideas on solving this question? So try to find out some sequence bn and cn such that an will lie between bn and cn. Okay, so let me show it how to do it. So one thing to notice in the beginning is that this is okay. Is this understandable? This is clear, right? Because as long as n is greater than 1, this is true. Similarly, is it clear? Just tell me, this is clear, right? Same thing. Similarly, you can show this as well, because for any number a, you can always write a greater equals to a. So this is implying that summation of k equals to 1 to n, 1 divided by square root of n square plus k greater equals to n divided by square root of n plus n, because we are doing just the summation. So you sum all the term on the left side, you sum all the term on the right side. So there are n terms on the right side, correct? So this will be just n divided by square root of n square plus n. So from here we can say an is greater equals to n divided by square root of n square plus n. Similarly, okay, 1 by square root of n square plus 1 is less equals to 1 divided by square root of n square plus 1. This we can write, correct? Again, 1 divided by square root of n square plus 2 is less equals to correct? This is also possible to write. Similarly, you can write n square plus n less equals to 1 by square root of n square plus 1, because the first term will be always the largest on that sequence. So that's why all the terms are less equals to the first term. And in the previous we showed that all the term are greater equals to the last term. So by summing, so if you take the sum, you will get this, right? Because you are on the right side, you are taking sum of n terms. So that means it will be n divided by square root of n square plus 1. And on the left side, you will get the sequence we have taken. Correct? So that means n divided by square root of n square plus n is less equals to an less equals to n divided by square root of n square plus 1. Correct? Is this clear to everyone? If this is clear, then there is nothing more to solve. Can just take the squeeze theorem, right? So, and this limit has, so let me call it as bn, let me call it at cn. So limit of bn equals to limit of cn is 1. This is true, correct? Let me show for one case. Indeed, limit of bn is limit of n divided by square root of n square plus n, and this is same as limit n tends to infinity 1 divided by square root of 1 plus 1 by n, sorry, n square. No, this is okay. Yeah, it will be n. Where is it? is okay, right? Or so this will be 1 divided by so this will be square root of n plus 1 by n. Is it okay? So this will be 1 plus 1 by n square. This one will be term, right? Yeah, this is okay. So this is 1. This will be just square root of 1 plus 1 by n, not 1 by n square. And for limit of Cn, so this will be n divided by square root of n squared plus 1. This will be limit n tends to infinity. 1 divided by square root of 1 plus 1 by n square. And this limit is also 1. So in the beginning I got confused with the square root. So I thought it will be 1 by n square. So yeah, it will be 1 by n, right? So both bn and cn has limit 1. Correct? So by squeeze theorem, or whatever you say, sandwich, squeeze, or mousetrap principle. Limit of n is 1. Okay, so this all I have discussed I think in the second class probably. What is a sandwich theorem or squeeze theorem or mousetrap principle, all the same thing. So by that theorem we can show that limit of n is 1. Is that clear to everyone? Is it clear to everyone? Okay, Ranjit says clear. So I hope it is clear as the crystal water. Crystal clear, right? Okay, so sorry. I'll go to the next question, which will be question number 8. So the next question is evaluate n factorial to the power 1 by n by yeah. So this is the question I was talking about in question number 6 to use this third fact. So now can you guys try, like, give it a go and try to see that what sort of limits is coming. Okay, so I think I will not give the options, so you guys find out what will be the answer. Ranjit, you can try. Binu, Dibalochan, Dipasri, Nilofar Math, you guys all can try. So other 2 people also has joined, I can see. So you guys also can try to solve this question. And if you have missed, since you have missed the first few questions, this video will be uploaded in the YouTube, and the notes will be also uploaded, so you guys can look at it later, and if you have any doubts when you are reading those notes, then you can ask me in the next class. Okay, so yeah, give it a go, give it a try, and just let me know. Yeah, anyone? Any solution do you guys have? You can just comment on the chat if you think any numbers can be an answer for this limit. So yeah, I think let me go to the question number 6. So yeah, this fact 3 I shared that you can write it like a theorem, that if n is positive, limit of n plus 1 divided by n is a, then limit of n to the power 1 by n will be also a. So you have to use this theorem as a theorem. Okay, so I'll write it here again. So let n be a positive sequence such that limit of n is a, and limit of n plus 1 divided by such that limit of n plus 1 divided by n is a, then limit of an power 1 by n is also a. Okay, so you have to use this theorem. This proof is also nicer, as I have mentioned earlier. So you can see the book of Schemapper and in the standard book, then you will see the proof there. So I encourage to see the proof in the book, but for now try to apply this theorem and get the result, because understanding a theorem and the proof is of course not easier, and even though if you can understand the proof of a theorem, it is not necessarily that you can apply it for a problem. So the good part or the main part of a theorem is always to apply and solve some questions. Okay, so this is one such case. So please apply this theorem for this problem and try to find out what will be the limit of n factorial to the power 1 by n whole divided by n. Okay, so can anyone tell me what we should take an for this question? Ranjit, can you tell me? Or Binu, Divyalocan, you guys can tell me what to take an? So you see that finally we want to show that n to the power 1 by n is a, right? So that means we have to take n in such a way that after taking the power of 1 by n, we get our this term. Exactly. So yeah, the first three is correct. We have to take an to be n factorial divided by n to the power n. Yeah, Ranjit, yeah, this is true. This is correct. Ranjit is also correct. So take an to be n factorial divided by n to the power 1 by n, because after that if you can show that limit of an plus 1 by an is something, let's say some finite number, then after taking the 1 by nth power, this n will get cancelled out on the power, right? Then it will be n factorial to the power 1 by n divided by n. So let us try to see what is limit of an plus 1 divided by an. So this will be limit n tends to infinity n plus 1 factorial divided by n plus 1 to the power n plus 1 into n to the power n divided by n factorial. Correct. So n factorial will get cancelled out because n factorial is always there inside n plus 1 factorial. So this will be n plus 1 into n to the power n divided by n plus 1 to the power n plus 1. Okay, so now you see that n plus 1 will be also cancelled out, because on the bottom there is n plus 1 to the power n plus 1, which is n plus 1 to the power n into n plus 1, correct? So this is same as this one, correct? Because n plus 1 power n get cancelled out, correct? And this is same as correct. So you can just take the power inside, like outside. So it will be n divided by n plus 1 to the power n. So this is 1 by 1 plus 1 by n power n. Okay, so now give it a pause and try to think if you guys know the limit. So do anyone have any idea? This is a very famous limit, very very famous. Yes, so 1 plus 1 by n to the power n converges to e. Yeah, the whole limit will be 1 by e, but the denominator will converge to e. So this is a very famous things, famous sequence that I want to try to connect. That by using this, you see that a lot of things can be connected here. By using this, you can show that the set Q is not closed. Do you remember? I asked this question in question, I think in week 3 classes, that I showed that for any irrational number there is always a rational sequence that converges to that irrational number. So this is one such sequence, that for the irrational number e, this 1 plus 1 by n to the power n is a sequence of rational number, because whatever n you put, this will be always a rational number, correct? And limit of this sequence is an exponential, or e to power 1. So this will be just 1 by e. Okay, so please try to see, there is a proof for that also, why this limit is e. Okay, this is also given in the book of SK Mappa. This is what I personally recommend, or you can see any other books, or you can try to find out in the internet as well. So then by the above theorem, limit n tends to infinity, n to the power 1 by n is just n factorial to the power 1 by n divided by n is 1 by e. Because I said earlier, if limit an plus 1 by n has limit a, has a limit, then n to the power 1 by n will also be a, the limit of n to the power 1 by n. So in this case, after taking the power, because an was chosen like this, correct? So if you take the power, it will be n factorial to the power 1 by n, and then the denominator it will be just n, because n power n will get cancelled out. And this is what we want, right? We want n factorial to the power 1 by n, and in the denominator we want n. So that's how we chose our an, correct? Is this clear to everyone? Is it clear to everyone? Yeah, Ranjit Nilofar Maths Department said yes. What about others? Binu, Divya Lochan, you guys are getting it? Okay, so Divya Lochan has put a thumbs up. That means yes. What about Binu? Binu, did you get it? This was an interesting question, right? A rational sequence is converging to an irrational number, correct? So that's why Q is dense in R, right? For any real number, there is always a sequence in Q which will converge to that number. For rational, it is easy. For irrational, I have shown it already in week 3 by using the Vox function, but this is a particular example where for the irrational number 1 by e, you can find that sequence n factorial to the power 1 by n divided by n. Okay, Narayan said yes. Okay, so then let me go to the next question. Let me see some interesting one. Okay. Yeah, this is a very, 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 very important question. I'm gonna write it here. Okay. Let c greater than 1. Find out limit n tends to infinity. So for this question, I will give it a 5 star. Okay, not a 1 star, 2 star, 3 star, or 4 star. So this is so important question. You might face in competitive exam. Definitely you will face this question if you give like few times, or if you see like previous questions. Ranjit, the answer is not 1. Answer is not 1 actually. So let me see if there is any answer. They have not given yeah, I don't think the answer will be 1, but yeah, let me solve it and then we'll find out. I do not know what will be the answer. Yeah, I do not know. Let me check. Anyone? So there are many ways to solve it. But yeah, I can choose the first one. There is a direct straightforward one. That is like change of variable. Sometimes you can change the variable and then you can try to find out the limit. So yeah, probably let me show it. So you take Tn to be log c divided by n. Okay, so then see that limit n tends to infinity is 0. Okay, after that I will show another way by similarly change of variables. So this is limit n is 0 because log c is a constant, and since it divided by n, it will be going to infinity, n will be going to infinity, so Tn will be going to 0, right? And from here, one thing to notice is that exponential of Tn is c to the power 1 by n. Correct? Because Tn is log c by n. So if you take e to the power Tn, it will be e to the power log c by n, and which is same as c to the power 1 by n. Correct? Because this will be e to the power log c by n, and this is same as e to the power 1 by n log c, and this is same as e to the power log c to the power 1 by n, and this is same as c to the power 1 by n. Okay, so now you see that our whole limit changes to this thing. Okay, let me write it here. So what is n? So our Tn was log c by n. So this will imply n is log c by Tn. Correct? And what about c to the power 1 by n? So c to the power 1 by n is exponential Tn. Correct? Correct? So our whole sequences changes into the second sequence. Correct? Now we already know as limit t tends to 0, e to the power t minus 1 by t is 1. Isn't it? This we know, right? By L'Hopital rule. So this will be just this is limit n tends to infinity, or you can take log c out because this is a constant, e to the power Tn minus 1 divided by Tn. Now as n goes to infinity, Tn goes to 0. So that means this Tn will act as a sequence for the function exponential of t minus 1 divided by t. Correct? Then by the sequential criteria of limit, you can show that this limit is just log c, because this is just 1. Is this clear to everyone? A lot of things are going on, right? So this is I'm using is the sequential criteria from here to here. Sequential criteria of limit. So that means if limit t tends to 0, exponential of t minus 1 divided by t is 1. Then if the sequence Tn goes to 0, exponential of Tn minus 1 divided by Tn will be 1. Okay, so sequential criteria of limit looks like this. If limit x tends to a, f of x is L. Okay, then if xn converges to a, let's say there is a sequence xn, then limit n tends to infinity, f of xn will be L. This is what I am using. This is called sequential criteria of limit. Similarly, there are sequential criteria for continuity. So that you will be seeing later. So this is what I am using. So you see that we have proved that limit t tends to 0, exponential of t minus 1 divided by t is 1. So that means if a sequence tn converges to 0, then the function f of tn here is just exponential of tn minus 1 divided by tn will converge to 1. Okay, is it clear? Then this limit is 1, so this is just log c multiplied by 1 and just simply log c. Is it clear to everyone? And there is another approach, is that you take c to the power 1 by n to be I don't understand what he said, Ranjit. I am expand e to the power 1 by n cancel. I mean, like you're saying that you are expanding c to the power 1 by n? I don't understand how do you cancel out. Okay, so you're saying the limit of t tends to 0 e to the power t minus 1 divided by t is 1. This is easy to find out, right? You can do it by expansion. You can use L'Hopital rule, whatever you want. This is 1. This is true, right? This is, you can use expansion of exponential t, which is just 1 plus x, like 1 plus t square by 2 factorial and so on. So e to the power, yes, yeah, this is what I'm saying, right? This is what I'm saying, right? So e to the power t minus 1 will be just t plus t square by 2 factorial and so on. So if you divide by t, the first t will get 1 and the other t will be all 0 because of order of t square. From starting, how can you use that? This is not c, this is e. I mean, this is not e, this is c. This is c, not e. C, it is not, yeah, it is c, not e. Oh, okay, that's why you said the answer is 1, because you said log e. Maybe you understood it wrongly. So yeah, indeed the answer will be log of c. Okay. So another approach is you can just take tn to be c to the power 1 by n, and then similarly you can do it using sequential criteria. The limit will be log c. Okay. So I hope this is clear for everyone, and if not, you can go through the video again later. Yeah, so then this is it for today. Is there any doubt? Otherwise I'll stop here. I mean, is there any doubt, anyone? This is the last chance to ask questions. Divalochan, Binu, Ranjit, Dipasri.
C and T are confusing. C and E, which is C and which is E is not clear.
Okay, so my handwriting is a little bit not good actually. So yeah, let me. So this is C. Okay. This is E. This is also E. Okay, this is C. This is also E. This is C. this is C, this is C, this is E, and this is C. Okay, and this is also C. Yeah, is it clear now? This is E, and this will be also C. Is it clear now for everyone? What is C and what is E? So that uh, dot in the middle is the C and the gap is the E. Okay. Yeah, so okay, then that's it for today. We'll meet on 23rd, which is Sunday, from 3 to 5. Okay guys, see you and good night.